Hi, my name is I'm Batrisha binti Roslan. Now I am going to present my PSM1 where the title of my research is Early Detection of Parkinson's Disease Using Machine Learning. So this is the overview of my research content. We will start with Chapter 1, Introduction, Chapter 2, Literature Review, Chapter 3, Research Design, Chapter 4, Proposed Work, and lastly, Chapter 5, Conclusion. We will begin with Chapter 1, the Introduction. Parkinson's disease, or PD, is a prevalent neurodegenerative disorder resulting in the loss of brain cells affecting millions worldwide. It is the second most common neurodegenerative disorder after Alzheimer's, with both genetic and environmental factors playing a role on its onset. Its progressive nature poses significant challenges for patients and caregivers. Characterized by the loss of dopaminergic neurons in the brain, PD manifests with motor symptoms like bradykinesia, which means slowness of movement and speed when moving, and rigidity means stiff or inflexible muscles, which can lead to disability in daily activities. In the recent years, machine learning has emerged as a powerful tool in medical prediction and diagnosis. Machine learning algorithms are designed to analyze large sets of data to identify patterns and make predictions. In the context of Parkinson's disease, this algorithm can analyze data from various sources such as patient records, genetic information, and brain imaging to improve diagnostic precision. Parkinson's disease might be a debilitating condition with a profound impact on patients and caregivers. However, advancement in machine learning shall offer hope for improved diagnostic accuracy and early intervention. Next, we will look into problem background. Diagnosing Parkinson's disease is challenging due to the absence of definitive tests. Currently, diagnosis relies heavily on subjective clinical evaluations, which can vary significantly in accuracy. This reliance on clinical judgment often leads to misdiagnosis, resulting in missed treatment opportunities and a decline in patients' quality of life. Delayed diagnosis further worsening the situation, as early intervention is crucial for managing symptoms and slowing disease progression. Additionally, the limited experience in handling large data sets restricts researchers from fully utilizing clinical data, which hinders progress in PD research. This gap in data analysis prevents the development of more accurate and reliable diagnostic methods, which will give impact to overall understanding and management of the disease. The problem statement is that the current methods of diagnosing Parkinson's disease are primarily clinical, costly, and time-consuming. These limitations can hinder early detection and intervention, which are crucial for managing the disease effectively. Consequently, there is a pressing need for a more efficient and accurate diagnostic approach, which is by utilizing machine learning techniques to improve the prediction and early diagnosis of PD, offering better outcomes for patients. Moving on to research aim and objectives. The aim of this research is to develop a machine learning model for predicting Parkinson's disease with a focus on achieving high accuracy rates. And the objectives are to study the random forest algorithm for feature selection to predict early stage of Parkinson's disease. The second one is to develop random forest algorithm for Parkinson's disease prediction. And the third one is to evaluate the performance of random forest algorithm in terms of accuracy, precision, and recall. Next, what is the scope of the research? So this research is focused on predicting Parkinson's disease, and the data set used in this project focused on people with early stage Parkinson's disease and was obtained from the UCI Machine Learning Repository with 21 features and 5,875 instances. The performance measurement is based on accuracy, precision, recall, root mean square, and mean absolute error. This is performance measurement for regression model. And lastly, the programming language used to run and test the algorithm in this project is Python. The importance of this research lies in its potential to revolutionize the way Parkinson's disease is diagnosed. By providing a solution to predict Parkinson's disease using machine learning, it can significantly improve the accuracy of disease prediction. This has the potential to positively impact healthcare practices by offering healthcare professionals a powerful tool for early detection and intervention. Next chapter will be chapter 2, which is about literature review. In previous studies, various methods have been employed to predict Parkinson's disease. The benchmark paper here used decision tree and some regression models, and the performance involved accuracy, root mean squared error, and mean absolute error. Therefore, my research aims to enhance these results by using random forest. Initially, my research will focus on regression models, as what benchmark paper has done, but by utilizing random forest for feature selection. The rest research shown here is to demonstrate that random forest consistently achieves high accuracy in predicting Parkinson's disease. So by comparing these results with those from previous studies, it is evident that random forest offers a significant improvement in predictive performance. Now, let's look into chapter 3, the research design. This study is structured into several phases, each with specific objectives. RO1 is to study the random forest algorithm for feature selection to predict early-stage Parkinson's disease, involve phase 1 and phase 2. Phase 1 is about the research planning and preliminary results. This includes conducting a literature review to understand about Parkinson's disease diagnosis. The study then continues with problem identification followed by data collection, while phase 2 focuses on preparing and pre-processing collected data. Activities involve descriptive analysis, data pre-processing to ensure quality and consistency of the data, and lastly, data normalization. This RO1 will be achieved in PSM1, while RO2, the development of proposed model, and RO3, the research evaluation, will be achieved in PSM2. Next is the dataset. The dataset used in this research was obtained from the UCI Machine Learning repository and consists of 5,875 instances and 21 features. The target class is the total UPDRS, which means the measure of the Unified Parkinson's Disease Rating Scale, and is located in the last column of the dataset. Now is the performance measurement. The performance measurement involve accuracy, correlation coefficient, mean absolute error, and root mean squared error. So this performance measurement is for regression model that will be used in this research. Before moving on to the last chapter, we will look into chapter 4, which is about proposed work. The data preparation involves these 4 steps: data cleaning, data transformation, data normalization, and data balancing. Now we will look into all the steps carefully. For data cleaning, the subject column was removed to generalize results across various patients. And next, the test time column was transformed into test week. This conversion to test weeks helped reduce noise caused by random variations in daily or hourly data collection. For data transformation, a new class was created based on the total UPDRS score to categorize stages of Parkinson's disease. This transformation resulted in 2 stages, stage 1 and stage 2, both considered early stage PD, aligning with the focus of this research. The next one is data normalization. Min-max scaling was applied to normalize the dataset. This transformation scales each feature to a predefined range, which is between 0 and 1. Normalization helps prevent overfitting or underfitting of the data, ensuring fair comparison and accurate model training. And now the last one for data preparation is data balancing. Due to significant class imbalance in the original dataset, where one class was heavily underrepresented, synthetic minority over sampling technique, which is SMOID, was employed. SMOID balanced the class distribution by generating synthetic samples for the minority class. This approach reduces the original imbalance ratio, ensuring each class is equally represented the dataset. So balancing the dataset with mode will help prevent biased predictions and improve accuracy, particularly for minority classes. For feature selection part, the random forest importance is used. The random forest importance falls under embedded method. So this method was employed to rank the features from most to least important features based on their contributing to predicting Parkinson's disease. A threshold was set to determine the number of features selected for the final model. So this is the results as shown here, and the mean accuracy for the selected features is provided. We can see that the more features are there, the greater the accuracy. So this kind of feature selection might not be contribute to the improvement of accuracy. However, since the benchmark paper did not provide what feature selection they use, so this is just an experiment to explore different approaches and their impact on prediction accuracy. In this phase of the study, initial results were obtained without employing feature selection techniques, allowing for a direct comparison with the benchmark paper's finding. So, this research achieved slightly better performance compared to the benchmark paper in terms of RMSE and MAE metrics. Additionally, correlation coefficient analysis was conducted, providing further insights that were not present in the benchmark paper. Even without using feature selection for the initial result, this result established a baseline for evaluating different methodologies effectively. So, since the benchmark did not balance the data, it might be the reason why this research performed better than the benchmark paper. Now, moving on to the last part of the presentation, which is Chapter 5 about conclusion. Throughout this study, several key achievements have been accomplished. First, studying Parkinson's disease and successfully classified its stages based on the target class value. And then completed data cleaning and pre-processing. These include removing unnecessary columns, transforming the target variable into stage, data normalization, and data balancing, and also applied the random forest algorithm for feature selection. The research constraints include limited access to public datasets, where future data collection from additional medical institutes is recommended to enhance the proposed model. The challenge also involves the need to determine the correct range for a stage given that the target classes consist of continuous values. Lastly, future work will be focused on further implementation and exploration of random forests to enhance predictive accuracy in classifying disease stages or predicting disease progressions. Additionally, future works will involve different feature selection techniques to ensure better results. That's all for my PSM1 presentation. Thank you.